In this lecture, we're going to discuss Lewis bonding theory. Now, this is going to focus on covalent bonding. The majority of this lecture actually will focus on how atoms bond together covalently. Now that we've talked about ionic versus covalent, we won't revisit that till we talk about bond strength. So, Lewis bonding theory focuses on the behavior of just the valence electrons in an atom. Remember, these are the electrons that are in the outermost shell of the atom. And really, it means that they're the electrons that are furthest from the nucleus. And so that means they're going to be the electrons that really interface with the rest of the world. Lewis bonding theory states that atoms are going to form bonds because that bonding results in a more stable electron configuration. And if you think about it, a valence electron has the least attraction to the nucleus of all the electrons in an atom. And those attractive forces with an opposite charge are very stabilizing. And so if it can form an attraction to another nucleus, that would stabilize those valence electrons and really lower their energy. So bonding occurs because it stabilizes the electron configuration. Atoms are going to bond together by either forming ions or sharing electrons. And the sharing of electrons is what we're going to focus on next. So usually this is going to result in atoms either obtaining an outer shell with 8 electrons by forming an ion, or by sharing electrons to have a sense of 8 valence electrons around it. Now, 8 valence electrons matches the electron configuration of a noble gas. And we know noble gases are extremely stable. There's an incentive to have the same electronic environment as a noble gas to obtain some of that stability of the configuration. And that brings us to the octet rule, which is really a foundation of building Lewis structures and thinking about Lewis bonding theory. So the octet rule states that atoms will form ions or covalent bonds to gain a noble gas-like electron configuration, or 8 valence electrons, hence the octet for 8. So here is a look at Lewis structures through the lens of the octet rule. So a Lewis structure coming out of Lewis bonding theory is going to represent the valence electrons of a main group element as dots surrounding an element symbol. So oxygen is right here. I would write its element symbol in the middle, like I did, and then surround it by 6 valence electrons, because oxygen has 6 valence electrons based on its group that it's in. And so the way I'm going to place these electrons around my element symbol is I'm going to imagine that it has these 4 sides, 1, 2, 3, 4, and I'm going to place the electrons around it essentially in a box. And so I'm going to always put 1 electron on each face of that box around the element symbol first. So I've got 1, 2, 3, 4. Then I'll start pairing them up. So oxygen has a total of 6. So I need to place 6 electrons around it. So I'll pair up 2 of my last 2 electrons with others and have 2 unpaired electrons. So that's in contrast to doing something like 1, 2, 3, 4, 5, 6. That is not going to be a Lewis symbol that we can use in Lewis dot structures. So 1 around each face of each side of my electron dot symbol before I start pairing them up. So then Lewis theory states that it's going to try to achieve an octet of valence electrons around it. So if it's going to form an ionic bond, it's going to take 2 electrons. Right here, I have them in blue, and I'll highlight them. Those electrons, or when those are placed, they're going to be placed in the 2 open kind of spots in my Lewis structure. And it'll show a full octet and a -2 charge when I've added 2 electrons. Now, since we've just talked about the electronic structure of an atom, we can clearly see that this is not a representation of how these electrons are existing in this atom at all. This is a bookkeeping method that helps us predict stable structures. So we've kind of layered our own sort of algorithm on top of covalent bonding with Lewis theory to make it easier for us to make predictions. And that's all this is. Okay, so the other way this oxygen atom can achieve an octet is by sharing electrons. And so we have our ionic bonding here when it takes 2. And now we'll look at covalent, if I can spell it, by looking at what happens when oxygen bonds with two hydrogen atoms. So remember, each hydrogen atom has one valence electron. So I'd write its electron dot symbol like this. And so what happens is the hydrogens match up to these unpaired electrons in my oxygen Lewis symbol. And we say that these are shared right here. So now if I count the electrons that are shared, which is the hydrogen sharing an electron with the oxygen and the oxygen sharing an electron with the hydrogen, I can now say that my oxygen has 8 electrons total around it, including the ones that it's sharing. And so that's how we use the octet rule to predict how covalent bonds will form and the charge on an element as well, as it prepares to ionically bond to another ion.